Hello students, welcome to my channel CGAT Maths. Myself Dr.Suresh brother. In this video, we are going to discuss the statement and derivation of Cauchy-Riemann equations in Cartesian form. Okay, first let us define the statement. The statement is the necessary condition for fz is equal to u of x comma y plus iv of x comma y may be analytic at z is equal to x plus iy is that there exist 4 continuous first order partial derivatives dou u by dou x, dou u by dou y, dou v by dou x and dou v by dou y and satisfies the equations dou u by dou x is equal to dou v by dou y and dou v by dou x is equal to minus dou u by dou y, or simply you can also write it as ux equal to vy and vx equal to minus uy. Okay, this is the statement of Cauchy-Riemann equations in Cartesian form. That is the necessary condition for fz may be analytic at the point z is equal to x plus iy is that there exist 4 continuous first order partial derivatives and satisfies these equations. Okay. Now the proof is very simple. Let us go for a proof. Okay. Given fz is analytic at the point z, by definition of analytic, f dash of z is equal to limit as delta z tends to 0 f of z plus delta z minus f of z divided by delta z, this limit that is exist and it should be unique at the point z and in the neighborhood neighborhood of z. Okay, fine. Now, in Cartesian form, we are going to take f of z is equal to u of x comma y plus iv of x comma y. Also, the point is z is equal to x plus iy. I need to get delta z by using the total derivative rule. Delta z is equal to dou z by dou x into delta x plus dou z by dou y into delta y. So let us differentiate z with respect to x, you will get 1. Similarly, z with respect to y is just I. The substitute here, you will get delta z. Delta z is equal to, this is just 1 into delta x plus this is I into delta y, or delta z is equal to delta x plus I delta y. So let us substitute fz, and also we need to substitute f of z plus delta z. Okay, here we are given increment to z as a delta z. Correspondingly, you need to give the increment to x as well as y. X becomes x plus delta x and y becomes y plus delta y plus I times of v into x plus delta x comma y plus delta y. Fine. Now the given equation, so you call it as equation number 1. So then this f dash of z becomes f dash of z is equal to limit as delta z tends to 0. F of z plus delta z value is, you can substitute it. Fine. That is u of x plus delta x comma y plus delta y plus I into v of x plus delta x comma y plus delta y minus f of z value is u of x comma y plus iv of x comma y, okay, divided by delta z. Okay, so in the next step I am going to take real and imaginary part separately. Limit as delta z tends to 0. So real parts are u, imaginary parts are v here. So u of x plus delta x comma y plus delta y minus u of x comma y. Next, iv of, you just look at v value. The coefficient of v are I, you can take I outside and write v of x plus delta x comma y plus delta y minus v of x comma y divided by delta z. Look at here, delta z is the LCM, and there is a limit outside. Okay, So first I will write delta z separately. Then I am going to write limit of a sum. So limit as delta z tends to 0. This is u of x plus delta x comma y plus delta y minus u of x comma y divided by delta z plus I times of p of x plus delta x comma y plus delta y minus v of x comma y divided by delta z. Okay, fine. So left side is f dash of z. Okay. So let us go for next step. Next step is the limit of a sum is equal to sum of the limits. Okay. F dash of z is equal to limit as delta z tends to 0 u of x plus delta x comma y plus delta y minus u of x comma y divided by delta z plus I times of limit as delta z tends to 0 v of x plus delta x comma y plus delta y minus v of x comma y divided by delta z, and call this as some equation number 2. Okay, fine. So further we have two cases here. The cases are, get the case 1. What is case 1? We have, student, we have delta z is equal to delta x plus I delta y. Okay. First what I am doing is substitute delta y equal to 0 here. Delta y equal to 0 means the delta z value becomes delta x. And you know that here as the delta z tends to 0, as the delta z tends to 0, which implies delta x tends to 0. Okay, fine. So now the equation number 2 becomes 2 implies f dash of z is equal to limit delta z becomes delta x tends to 0 u of x plus delta x, right, as it is. You can substitute delta y equal to 0, then you will get y only here, minus u of x comma y divided by delta z is equal to delta x plus I times of limit as delta z becomes delta x tends to 0 v of x plus delta x, right, as it is. This delta y becomes 0, just you have y, minus v of x comma y divided by delta z becomes delta x. Students, look at carefully. Left side is f dash of z, and look at this total term. This total term is the definition of partial derivative of u with respect to x. Look at here, only x changes. X becomes x plus delta x, y remains as it is. So this is the definition of dou u by dou x plus similarly I times of this will become the derivative definition of v with respect to x. Call it as equation number. Hope you understand the definition. Okay, we have written these are the standard definitions of a partial derivative of u with respect to x and v with respect to x. Now let me go for case number 2. So in case number 2, what I am going to do, as usual, you have already delta z is equal to delta x plus I delta y. you need to substitute here delta x equal to 0, then delta z becomes I delta y. Okay, so substitute here delta x equal to 0, you will get I delta y. And as delta z tends to 0, which implies delta y or I delta y tends to 0 or simply delta y tends to 0. Now look at the equation number 2 becomes f dash of z is equal to limit as delta z means delta y tends to 0, u of delta x is 0. Okay. So x comma y plus delta y minus u of x comma y divided by this is I delta y, because delta z is equal to what is delta z is equal to I delta y plus I times of limit as delta y tends to 0 v of x comma y plus delta y, substitute delta x equal to 0 minus v of x comma y divided by I delta y. Okay, here you can take 1 by I outside, f dash of z is equal to 1 by I outside, and the remaining becomes the partial derivative of u with respect to y, that is dou u by dou y plus here I and I get cancelled, the remaining becomes dou v by dou y. Okay. Further, this f dash of z can also be written as, here you have 1 by I. How do you write 1 by I? I am writing here, look at 1 by I is equal to, you can multiply and divided by I. So I divided by denominator becomes I square. I square becomes minus 1. I by minus 1 becomes minus I. So I am writing this as minus I into dou u by dou y plus dou v by dou y. Call it as 4. You can observe equation number 3 and 4 or compare 3 and 4. By comparing 3 and 4, left side is f dash of z in equation number 3, and in equation number 4 also it is f dash of z. Means left side are equal means right side are also equal. So what are the right side here? Okay, let me go for next slide. Compare equation number 3 and 4, and comparing what we get is the equation number 3 is dou u, right side is dou u by dou x plus I into dou v by dou x. For the equation number 4, right side is minus I into dou u by dou y plus dou v by dou y. Okay, now here equate real and imaginary parts. Equate real and imaginary parts. On equating real and imaginary parts, so what will we get? We get real part is, the left side is dou u by dou x, right side is dou v by dou y. So dou u by dou x equal to dou v by dou y, and equating a imaginary part, dou v by dou x equal to minus dou u by dou y. These are the Cauchy-Riemann equations in Cartesian form. That's it. Thank you so much for watching. We'll meet in the next video.